Hi, so we're going through a PAT paper in 2016 looking at question 10. So in question 10 we're asked to find the area between the curves y equals minus 2 minus x, y equals 2 plus x, and y equals x squared minus 4 for the area that includes the origin. Okay, so let's start by sketching these down. So we have an x and a y axis as always, and then we're going to sketch our curve. So let's start with the simple one, y equals x plus 2. So that's a simple straight line graph with a y-intercept at 2 and a x-intercept at minus 2. So that's going to look like this. What about 2 minus x? Well, that's going to have an x-intercept at 2, so that'll be when y is 0. So that's 2, that is minus 2, and that is 2. And then again, it's going to have a y-intercept at 2. So we're going to have it coming down through like this. So this is the curve y equals x plus 2, and this is the curve y equals minus x plus 2. And then, well, what about y equals x squared minus 4? So y equals x squared minus 4. We see that factors into x minus 2 and x plus 2. So we see that's going to have roots at, well, minus 2 and 2. So we're going to have that coming as a quadratic word down like this and through here. So what's the bottom point here? Well, when x is 0, y is minus 4. So it's going to actually have an intercept of minus 4. So let's try and do this a little bit to scale. So we're going to have minus 4. We'll keep that in blue. So minus 4 down here. So then we simply try and get it through the point, up like so. And similarly down like this. And now we see why they've said which includes the origin, because you actually have a region here and a region here where they actually intersect. So we're concerned with this region in here. What do we notice? Well, we notice that we actually have perfect symmetry. So we know this area is the same as this area, and this area is the same as this area. So if we call this area A and this area B, if we find A and B, we simply double A and double B and add them together to get our total area. And what we'll do is we'll just shade in our area so it's obvious. Okay, so what is area A? Well, clearly area A is equal to, well, we have a triangle and it's of base width 2 and height 2. So half base times height, half 2 times 2 is half times 4, which is simply 2. And what about B? Well, B, we see it's going to be an integral. But when we do the integral between, what integral is it going to be? We want to find this region here. So it's going to be the integral of the curve y equals x squared minus 4. So we'll just call that y equals x squared minus 4. It's going to be the integral of y equals x squared minus 4 between 0 and 2. But this is going to give us a negative region. So we have to take the modulus of that because it's a negative area. So we take the modulus of the integral between 0 and 2 of x squared minus 4. So b is equal to the modulus of the integral between 0 and 2 of x squared minus 4 dx, which is equal to the modulus of, well, that integrates to give us 1/3 x cubed minus 4x between 0 and 2. Well, that's equal to the modulus of, well, what's 2 cubed? 2 cubed is 8, so that's 8/3 minus 4 times 2, 8. So that's equal to 8 minus 8/3. 8 is 24 over 3, so that's 24 minus 8, or 16 over 3. Well, therefore, the area is equal to 2a plus 2b, which is equal to 16 over 3 times 2, 32 over 3, plus 2 times 2, 4. Well, that's 32 plus, well, 4 is 12 over 3, so that's 44 over